Vectors in 3 space R3. So we have many ways of representing vectors in 3D. So here we have 4 of them. One is order triple. Now order triple is writing vectors as ABC, where ABC are the components of the vector and they signify the direction number. So ABC are basically, they belong to real numbers, one. Second, they're called components. They're also called components. And they're referred to as direction number. So I'd like you to make a note of these. This is just the very first lecture on notation. So remember these terms. And so whenever we have square brackets and the components, that is x coordinate, y coordinate, and z coordinate given to us, then it refers to an order triple, and it really refers to a position vector. So whenever given like this, we are talking about a position vector. Position vector with tail at the origin and head at ABC. Now, unit vector notation is representing these vectors in the form of ijk, where ijk are unit vectors along x, y, and z axis. So this is vector I, this is vector j, and this is vector k. So I is along x-axis, j is along y-axis, and k is along z-axis. So ijk, if I have to write this vector in the form of unit vector notation, then I can write this as a times I, since a is a component along x-axis, plus b times j, plus c times k. So at times for unit vectors, I'll write them like this. So it is the same vector written in a different form, and this form is unit vector notation. So as you can see, any vector, let's give it a name, let's say any vector p can be written as linear combination of ijk. And so we say that in 3D or in 3 space or in R3, ijk forms a basis. So a bias means that any vector could be written as a linear combination of scalar multiples of ijk. Row matrix notation. In row matrix notation, we'll write this vector almost same as we write in order triple. So, but that is a row of a matrix. Now, row matrix really helps us to do computation. So we are representing vectors in algebraic form in all these cases. Now it helps, the main idea here is to do some computation with these vectors, add, subtract, multiply, divide, and get some results. So the matrix notations help us for faster computation. Column matrix. In column matrix, we'll write this vector not horizontally, but in a column, like A, B, and C. So here the direction numbers A, B, C are written in one column. They mean the same thing. A is the direction number along x-axis, B along y, and C along z-axis. So it's a good idea to have them here at one place because we are going to switch from one notation to another depending on the type of problem in hand. For example, if you are solving simultaneous equations, in that case column matrix is a good idea. It helps you to do them much faster and efficiently. Row matrix is a good method to add and subtract the vectors. And a lot of applications where we resolve forces or velocities in different directions, unit vector plays a good role. Order triple is a convenient way of writing and is the general way in which we'll be performing most of the vector operations, right? So that is how we are going to use these vector notations in our videos. I hope you understand and you will have no difficulty here on when we switch from one notation to another. Thanks and all the best.